Welcome back to Front End Hire. Today we are going to build something I like to call as Stackpack. It is essentially a Sandpack clone but built with WebContainers API. And this course is very important if you ask me because it will teach you that we as front end developers can build something more than just simple CRUD apps. In fact, some of the knowledge from this course also enables you to build more complex apps like Lovable, Bolt, or even V0. So let us quickly see what Sandpack looks like. So this is their website, and from the definition, run any JavaScript and Node.js app in any browser powered by Code Sandbox. So you can essentially build a full online code editor experience using Sandpack, and it's all instant feedback, right? And you can play around with React, Angular, Svelte, Vue, any of these JavaScript languages, and even some Node.js part of things. So this is built by the team behind Code Sandbox. Now, and what is Web Containers? Web Containers is something similar, and this is from the rival team Stackblitz, and they say it's called dev environments in your web app, right? You can also, again, you can build interactive tutorials to full-blown IDEs. So both of these technologies kind of do similar things. Web Containers has a little bit of edge, and let us try to understand what it used to be like before Sandpack and Web Containers, right? Imagine you're building something like a coding practice platform, right? Something like Great Frontend, Lead Code, Algo Export, Algochan. Frontend Hire used to have it. I removed it, so I can't say that we have it anymore. So basically you want users to write code in the browser and see the output in real time. Or maybe you're building a new web framework and want to give users a way to try it out without setting up a dev environment, like how React or Svelte does, right? If you go to React docs, if you see they have a couple of examples, which is interactive. All of this happens on the docs. Nothing goes to the server, right? So this is a very good way to create a new web framework and show it out to the world. And even Svelte. Svelte have a full-fledged tutorial for Svelte and Svelte kit. And actually React uses Sandpack under the hood, and Svelte uses web containers. So you can see what's possible with both of them. So before Sandpack and web containers, we had a couple of options, which was something like CodePen or JS Fiddle. CodePen looks something like this. You would have your HTML, CSS, and JavaScript, and you can build it out. Quite limited with respect to experience and everything. And they're pretty much like a playground for vanilla JavaScript, HTML, CSS. You can run React, Vue, and Svelte, and pretty much because of the CDNs they provide, and it's not a great expense if you ask me. And it's honestly, many people just use it as a playground. I could not find any production examples of them using it on actual docs or something like that. Again, we have Code Sandbox and Stackblitz. These are the industry leaders, and they allow you to write code in the browser and see the output in real time. And the way they do this is through mini virtual machines, and in fact, and now some of them use their underlying technologies like Sandpack and WebContainers to pull this off. But yeah, you could embed these editors in your website, and again, you lose out on a bit of branding, but you could still embed these editors in your website, and feedback depends on the server's response time. And now that they use Sandpack and WebContainers, some of the frameworks are instant, all of those web frameworks. And in fact, Front End Hire now, the deprecated questions, uses this experience. So you see, this is a Stackblitz embed, and you get this experience. Don't worry about this. This happens because I'm on the browser Zen. I'll have a couple of things to worry about this, but if you're looking at this on a browser like Chrome, this should work out of box. So what is the other option which will give you full control over the branding is to have a custom setup. Basically, you build your version of Code Sandbox or Stackblitz. You send the input code to the server, and the server compiles the code and streams the output back to the client. This has completely unique experience because you get to build everything. But yeah, requires a server to compile the code. And the feedback also depends on the server's response time. And Algo Expert and Lead Code pretty much do this. There's also a framework called Jet0, which allows you to do all that validations of your test cases. That's what Algo Expert and Lead Code pretty much use, I believe. And again, if you've seen the docs too, right, with docs of Sandpack and web containers, they cannot run languages like Python, Java, etc. Right? These are pretty much meant for your front-end languages like React, TypeScript, JavaScript. But web containers has the ability to run these through something called as VSCode. It's a little complicated. I've linked this in the docs so you can go check it out. But how do these work pretty much, right? First, again, let's go through the definition again. What is Sandpack? Sandpack is an open ecosystem of components and utilities that allow you to compile and run modern JavaScripts in the browser. And web containers? Web containers are a browser-based runtime for executing Node.js applications and operating system commands entirely inside your browser tab. So Sandpack gives you components and utilities. Web containers just gives you the runtime so you can build your stuff on top of it. So yeah, again, another example here, regular server approach. User writes code and clicks on run or is debounced. That is sent to the server compiles the code and streams the output back. With web containers and Sandpack, everything happens in the browser. This has way too many advantages, such as instant feedback, you don't have to maintain any servers, it's cost effective, again, because you don't maintain a server, and it is also secure. Trying to handle this means you'll have to also deal with any of the potential attack vectors, so you'll have to secure your code compilation. So yeah, if it happens on the client-side browser, you don't have to worry about security there. With regards to cost effective, let me tell you, these are not open source and their license is limited. You'll have to read about where it's free and where it's not free. But essentially, I think these would still be very cost effective compared to regular servers. Again, you can read more about this. But like I said, with Sandpack, you get a full-fledged UI, components and utilities. Web containers, you don't get that. So in this course, that's what we're going to do. We are going to build the components and utilities for web containers. And here's the course overview, quick overview again. You have a code editor, you have a terminal, and you have a browser output. It's pretty much the preview panel for you. And just these three components will involve way too many things. First up is the Monaco Editor. If you don't know what Monaco Editor is, it is the actual editor that also powers your VSCode editor. We will use the React wrapper to build our application on top of it. We will be using web containers, of course. And then we have something called as Xterm.js. It is the terminal emulator. Again, this is also the same terminal emulator that VSCode editor uses. So we are using pretty much industry standard technologies for this course. And again, we have some basics, ResizeObserver, React, TypeScript, Tailwind, React resizable panels, because you see I have these panels to resize the editor, browser output or terminal, and some more utilities like CLSX and Tailwind merge. I assume that you know some amount of React, TypeScript and Tailwind. Tailwind is completely optional. You can just ignore the class names I write. And I can't say that this is a full-fledged product. It's going to be pretty much a prototype. So we will try to be as production ready as possible, but it's a prototype. And also don't worry about design. We'll just focus on the functionality. Some more links attached here, but yeah, in the next section, we will set up the project. All right, now let us set up the project. I have created a GitHub repository with the initial setup to make it easier for you. You can fork or clone the repository. This is the URL. I'm just going to clone this. And next, I want to run the following command so that I have my dependencies installed. I'm using pnpm in my repository, so make sure you have it. And yeah, make sure you're on the 0 start branch too. I just have to run a couple of commands so that I'm not making any changes to the actual repository. So this should help me. You don't have to run those commands. Okay, now let us also open the repository in an editor. Next. So we use Tailwind in our application, and this is not a Tailwind course, but I want to quickly show you how to install Tailwind. We are using Tailwind version 4. You can follow the official documentation steps too. But here I just have to install Tailwind CSS and the Vite plugin for it. So let me open my terminal. So pnpm add Tailwind and Tailwind CSS Vite. Cool. And next what I have to do is I have to configure my Vite configuration and initiate Tailwind over there. So if you look for Vite config.tss, you just have to bring Tailwind CSS and import it from the plugin. And this should pretty much set up Tailwind CSS for you. One last step is to import the Tailwind directive, which is Tailwind CSS import. I'm just going to throw it in my index.css file, and this should pretty much set up Tailwind CSS for us. Let us also run the dev server. All right, let me bring up my dev server. Localhost 5173. Let me put this beside here. Okay. So looking at the font size itself tells me that Tailwind is properly set up. Next step. Yeah, we can also make some changes to our app component to see that Tailwind works. Go to app.tsx. You can replace the return statement with this and you'll see that hello world works. Yep, Tailwind is properly set up here. Great. Now, first up is you need to install the Tailwind CSS IntelliSense. Hopefully you have it. It's gonna look something like, where's my Tailwind? Yeah, this one. Tailwind CSS IntelliSense. Just search for it in your extensions. You'll find it. Install it. It makes working with Tailwind a lot easier. Next up, there's something also called inline fold, which is basically it's going to collapse all your class names so that it doesn't clutter your HTML. It's pretty much a visual thing which you see only in your VS Code editor. It doesn't do anything much apart from that. I don't use it. I like to see my styles over here. So if you don't like to do that, you can go install this extension. Now, since we will be working with Tailwind classes a lot, sometimes the order can be messed up, right? And having a consistent sorting order with your classes helps. And Tailwind has a plugin for it. It's an official plugin from Prettier and Tailwind. So you can just copy this. It's called Prettier plugin Tailwind CSS. It's a developer dependency. And all you have to do is go to your Prettier RC or whatever Prettier configuration file you have and create a plugin there, right? So plugins, Prettier plugin Tailwind CSS. Now I've saved it. If I go to my app.tsx and if I save now, you see it was automatically sorted. I'm just gonna show you again. I'm gonna text3xl underline font bold. Font bold will be in the middle now. All right, so that plugin works. Great. This was the initial quick project setup with Tailwind. If you work with Tailwind, make sure you have this plugin. It's a lifesaver if you ask me. In the next section, we will be building the layout. And anytime you feel like things are not working, at the end of every section, you'll find a project branch, which you can quickly check out and check what changes were missing. Great. Let us now build our layout. So let's see again the components involved. We have a code editor, we have browser output, a terminal, and we have something resizable panel. So I'm going to start there. We can use a good library, and one of such libraries is known as React resizable panels. They have a couple of examples, and you can see that again, this is one of the industry standards. Couple of players already use it, and it's a good package to have, and we're going to use the same package. So I'm going to install this in my project now. So pm add React resizable panels. Great. So what is the next step? In our app.tsx, we want to quickly structure a layout. So how React resizable panels work is for every set of resizable panels, you have a group and the actual panel. So the first panel group we have, let me quickly copy this and show you. I'm just copying that. I also suggest you do the same. Don't worry about writing it from scratch. So first panel group which we have is a horizontal panel group. I'm running my dev server. Let me refresh. You're seeing some things don't work as expected. Don't worry about it. We'll fix it in a second. So we have a preview, right? And we have a terminal, right? A couple of things are not working. I'm going to fix it soon. But yeah, it's a panel group and built with panels. So the first panel is your code editor and your terminal, right? The same thing which you see here, code editor and terminal is your first panel group, and the other panel group is the code editor terminal combined with the browser output, right? So you'll see the preview here. It's pretty much the browser output. So one panel here and another panel which comprises two more panels, code editor and the terminal. And you'll see this resizable handles. Right now you can't see anything. We're going to fix it soon. Yeah, like I said, your output looks quite weird at this point. So what I'm doing is I'm going to quickly pull up some class names. First thing is I'm going to give a full height and some padding, and then add some borders so that you see where your things are. Again, copy paste. Don't worry about writing it from scratch. Okay, now things are a lot better, but you see that code editor and the terminal and the preview don't take the full width. So let's see how we can fix that. Yeah, our app looks something like this. Oh yeah, we can't even see the handles now. So let's work on them. So I'm just going a quick class name to my panels. For the vertical panels, we give a height, and for the horizontal panels, we give a width. Again, copy paste, you won't lose any of the changes. Right, our panels are now quite evident. So that's a good thing. Okay, next we want to ensure that the code editor, preview and terminal devs occupy all the space inside the panels. Right now you see that it's pretty much a small space which they occupy. And we can do this with simple hrfull class name. Again, copy paste, you don't have to worry much about this. I just added the hrfull class name, which is basically take the full height. And now you can see that the code editor, preview and terminal occupy the full height available. So I think our layout already looks quite good now. So our layout should look like this now. Things won't look the exactly same. I'm updating the scores over time, so sometimes some dependencies change, so things might look little different, but pretty much everything should remain the same. So we can now pretty much remove the class, this utility helper background classes I added. In the next section, we will consider what component to make next. Should we build the code editor first? Should we build the preview first or the terminal first? So like I said, what should we build next? Should we work on the code editor or the terminal or the preview or the web container? There is literally no perfect answer to this. I already did a POC. I built this course myself, and I know that working with web containers first makes things easier as it drives most of the logic. But in this POC, I want to cover the components involved and go from a code editor first, web container next, terminal, and the preview next. So that's the structure I'm going to follow in this course too. Great. Let us build our code editor. Even though I'm saying it's build a code editor, it's more like assembling a code editor because they are extremely challenging to build from scratch. And there is honestly no reason to build something like that from scratch. We have a couple of great open source options. One is the Monaco Editor, the other is CodeMirror, and the other one is Ace. I've used both CodeMirror and Monaco editors. Both are great. CodeMirror feels a lot more lightweight and gives you a more minimalist experience. All of these editors are great and you can use any one of them. It doesn't matter whether you're using Sandpack or WebContainers. Sandpack by default uses CodeMirror, but this course will use Monaco Editor because that's the more robust editor if you ask me. And yeah, you can also read this great blog from I think Replit. Yeah, it's Replit. It's between AS, CodeMirror, and Monaco. They explain which one, like the differences between them. So as mentioned, we will be using the Monaco editor and we will use the React wrapper. Again, the command to install is pm add Monaco editor React. I'm just going to copy this. Okay, that's great. Let me run back my dev server. So what we can do right now is build our code editor components. So I'm just going to create a components folder, store my code editor there. Again, don't worry too much. You can just copy the boilerplate here. Right, I'm just copying this. I'm going to replace this code editor with the code editor I'm building. Code editor, VSCode should auto-complete it for you, right? I've replaced this with my code editor now. This is the step I did now. And now we can render the Monaco editor, right? Again, you can copy paste this. There's nothing for you to learn here. With the simple import from Monaco Editor React. I'm using a default theme of VS Dark. I think they also have VS. You'll find the configurations in the docs, but yeah, light looks something like this. And I think we as developers prefer dark. Even I prefer dark, so I'm gonna stick to that. Great. So yeah, you pretty much have the VS Code editor now. Const hello world equal to hello world. Yeah. But a couple of things I'm missing. It seems like it's acting as a text right now, right? We want to worry about what language we're using and everything. We'll get there. So yeah, the editor component takes a theme prop. We set it to VS Dark. Even if you omit it, it's going to take the default light theme. So this editor is quite special and there are a couple of gotchas. And in order to support multiple files with multiple languages, we want to use something called as multimodal editor. You can find it in the README about what a multimodal is, but essentially it allows you to work with different files and languages. Even before we do that, if you notice the Sandpack docs, they don't give you an approach to customize the template, the actual code template they give you. It's pretty much an after step. Because again, there are a lot of things you want to handle if you want to build your own template, but we can have a couple of pre-built templates and provide it to our web containers and even code editor. And that's what we're going to do now. We are only going to support React with Vite template. So essentially 5 files, an app.jsx file, index.jsx file, index.html file, package.json, and Vite config.js. Pretty much these are the essentials you need. So which is what we'll also have. And we will use an object to represent the files. Again, I'm not going to worry about folders in this course. You'll have to write a lot of additional utility functions and logics to handle that. To keep it simple, I'm going to just work with files in a single directory structure. So my idea is to use an object to represent the files. The keys would be the file names. and the value would be the another object holding more information about the file, such as the contents. Again, we can add a lot more things depending on node functionality, but for now, let us keep it simple with just the contents property. I'm gonna create a templates folder, and I think I'm gonna call it React v.ts, a TypeScript file. In fact, I'll just copy this entire template and I can explain things easy there. React v.ts. All right. Let me go over the types again. I have a type called code file. It has nothing but contents, and which would be string. I have a template type, my top level template, which will have a couple of files, and it's an object with key name as a file name and the actual content. And entry. What is entry? Entry is a file which I want to show first. And then another key, which I'm calling visible files. It is nothing but all the file names I want to make visible to the user. For example, you don't want to make package.json visible for some reason, right? So this will allow us to do that. And the actual template, again, I copied this from somewhere. You can also copy it right away, so don't worry about reading it. My entry file would be app.jsx. Visible files are app.jsx, index.jsx, index.html. I have my template ready now. So what is the next step? Now we will use the template and try to populate our multimodal editor. So again, let me quickly copy this. Right. I am using state to detect what my active file is going to be. All right. So I'm calling it active file, and by default, it's going to be the entry which I specify. Again, this is not storing the actual file, just the file name. We just need that. And the current file can be derived from the active file state. So current file would be from our template in the files, whatever the file name is. Now, in order to enable this multipath editor thing, you have to give a path to the file and whatever the default value is. And this would pretty much enable your editor. And you see, we can already see some good things. But wait, how do I switch between different files? So we will have to create a files tab. So again, I'm gonna copy my updated code, which is nothing but a list of my files and a button to navigate those files. So a quick CSS, don't worry about any of the CSS part of things. But yeah, you can see that my app.jsx, index.jsx and index.html. I can easily navigate between these files now. What has changed? Nothing. A simple unordered list with all the visible files. And when you click on the button, we just set the active file to that particular file. This enables our files tab. We can clean up the code by extracting the file tab into its own component. So I'm gonna do that. So let me create something called as file tabs.tsx. I've already copied it, so I'm gonna just put it here. I've created a quick type, which is nothing but active file on file change and the files. And I can just replace this here with my file tabs. Let me copy this here. Yep, I'm sending all the visible files as my files. The active file and the on file change is nothing but set active file. So yeah, code should be a lot cleaner now. None of the functionality is lost. So things are great. And if you ever use Shatcn, you would know these two libraries. That is nothing but CLSX and Tailwind merge. It's pretty much a utility. Just install it once and you would never have to worry about them again later, right? I'm going to install those dependencies and copy my utility file for that. I'm just going to store it in my utils folder. I'm going to call it class names.ts, copy paste, nothing but CLSX, TW merge. This is pretty much the file you need. Shatcn also uses something similar. In fact, I think it's pretty much the same. So feel free to build this utility. Now, how do we use that? In our files tab component, if you notice, let me copy this again. So let me show you the exact changes that would be involved by doing something like this. Right, in the class name section, you see that I did some conditional string stuff here. $active file if equals file name, this classes, otherwise nothing. So there's a possibility where Tailwind doesn't behave well when you do such stuff. And when you use the utility which we just built, the class name, these edge cases are handled, and it also makes it a lot easier to handle some conditional stuff. And yeah, you just build this utility once and use it everywhere you want to have conditional classes. It works like a charm. Okay, great. I think with this we are good to go. One more important thing to do now is to handle the editor's language. We have the file name, and file name will have the extension. So we can use that extension to derive what language it is. Again, we want to create a utility function to get the language from file extension. I'm going to call it get language from file name.ts. And it pretty much is a simple switch case, which takes a file name and decides what the extension is. If it doesn't matches, it's going to default to a plain text. Great. Now let me clear all this. It's a mess. Back in my code editor, I'm going to do a couple of things. I'll import my utility, get language from file name. It takes the active file, which will tell me what language it is. So TypeScript is helping me here, which you can see TypeScript, JavaScript, JSON, HTML, plain text. So the default language here is language. So now I think you'll have a little better editor support. Yep. Okay, this is great. So these are pretty much the basics of building a code editor. We have a multimodal editor, and we can switch between files and set their language based on the file extension. We also have a file tabs to switch between files. You want to build something complex, you can build a simple file explorer, support directories and everything. But for this course, yeah, this is pretty much it. If you go through the VSCode Monaco Editor docs, you'll find it a little confusing that there is value, there's default value, there's language, there's default language, there's path, default path, right? So the default prefix is used to set the initial value language path of the editor during its creation. This is also what enables a multimodal editor. Whereas the value, language, and path are used to update the editor's value, language, path after the editor has been created. In most cases, you can use the value, language, and path props. But wherever you have to support these files or a multimodal editor, you want to stick to the default ones, except for the path, yeah. It's there in the GitHub issues, you can read all about it. But for now, what we did is pretty much good enough. And in the next section, we will focus on building the web container. Let's come to the fun part, the WebContainer API. WebContainer API is the library that does most of the heavy lifting here. It runs the server within the browser. Again, the definition is, it is a browser-based runtime for executing Node.js applications and operating system commands entirely inside your browser tab. Let us install the dependency and quickly get started. It is a single dependency, WebContainer API. And how do we use it? Due to the technology of the web containers, we have to set up a couple of headers for our server. Otherwise, things will break and you want to do this. So in your readconfig.js, let me copy the entire file. We set up server headers just to make sure. So how does web containers work, right? Irrespective of what you use, you still have to install those dependencies and they have to come from somewhere. And in order to enable that, in fact, they come from the Stackpack servers, we need to set the headers. Otherwise, things will absolutely break. You even have to worry over this when you're deploying it for production. We'll discuss that. But for now, you have to set these headers. Don't worry too much about it. Set them and leave them. Now, we want to boot the web container instance. Again, quickly copy this. It's easier to explain that way. In my app.tsx, what I'm doing is I'm creating a state to store my web container instance. It's either web container, which comes from the web container API type, or it's null. So to begin with, it's going to be null. Now, web container API is a third-party library. It doesn't have a React version of it. So we'll have to build a wrapper, or we can simply use effect to synchronize with it. All we have to do is create the web container. The command is await webcontainer.boot, and we only have to run it once. Concurrently, you can only have one instance of web container. And if you know how React strict mode works, and if you run your dev server and check the console log, you will immediately see an error. Only a single web container instance can be booted at. Why is this happening? Even though we are running it once and there's no dependency here, In React strict mode, your effects are run twice. So that is the reason you're getting this error. If you remove your React strict mode from your index, I think it's main.tsx. If you remove this, your effects will only run once. But why do we even run effects twice? You can read about it, but it's essentially to catch a couple of bugs. In fact, even with web containers, you can do something like webcontainer.teardown, which would destroy the web container instance, turn it unusable and release it to the source. So this is how you do it in React use effect, right? You want to do a cleanup function. This is what essentially it is. But given the nature of web containers and it's still not open source code, and there's an active issue that is also tracking it. It's closed, but it's not fixed yet. Don't worry much about it. For now, it would just throw you an error, but the web container has been initiated, right? So we create the web container instance, we boot it, and we store that instance in our state. That's it. With this, we have your web container instance. And honestly, don't worry about your console log errors for this course at least. Now, remember I said we are working with web containers and it's doing heavy lifting. That means the file system should also be handled by WebContainer API. And it has its own way of, you can read the docs here, but I've already read them. So you can, for now, we're going to make some small changes to our template, existing template. Like I said, we are only going to be working with files. So WebContainer API has a file node, which we will use. It essentially makes changes of this sort. For all our files, we have the file name and then we have a file key, which is an object with contents. So don't worry about this. Copy this. When you're actually building something production ready, you can worry about that structure. For now, back in our templates, just dump whatever I gave you. And things will break in your code editor. Don't worry about it. We'll fix that in a minute. Now, like I said, WebContainer API also supports directories, but for our course, we are only working with files. So if it's a directory, instead of file, you'll have a directory key. So you'll have to write some more logic to handle that. Okay, now let us also update the code editor. What has changed is the current file now has contents, which has the actual content. So that's going to change. I'm going to copy this back in my code editor. Yeah, like I said, contents, it's current file and then contents. Okay. Now, why am I doing it as string? This is because the web container file system also supports something known as uint8 array. We can, of course, convert such a type to string, but for this course, we are gonna work only with strings. So this typecasting is completely fine. Let us see what the next step is. Again, like I said, this is the instance complain about multiple instances running or something. Our code editor knows about the files, but our web container still doesn't know about the files. So we have to mount the files to our web container. And where we booted our web container, the next step would be to mount those files. So web container instance .mount, even though I'm copy pasting code, if you're writing it yourself, you'll find full type safety, and web container instance has a mount where you mount all these files. Again, with this step, your web container is pretty much ready. And in the next two sections, we will actually wire up the web container API with the terminal and the preview. And that's where you'll be able to see how web container actually works. In this section, we will build the terminal. Why do we have to build a terminal? Because we want to interact with web containers, right? It's nothing but a shell process. Building a terminal will help us communicate with the web container API. And like I said, we're using something called as Xterm.js. It is the same terminal. In fact, yeah, this particular terminal you see here, this is the same terminal as Xterm.js. Okay, now we have our terminal installed with this command. Let us quickly do the boilerplate stuff, create a new component, terminal.tsx. And we can import it right here. Okay. And now let us actually bring in the Xterm. Again, I'm copy pasting some stuff. Do it. That's okay. So I'm importing the terminal from Xterm as Xterminal because my component is already known as terminal. So in order to avoid that conflict, alias it to Xterminal. If you look at this terminal, you immediately know that it needs some styles. but luckily Xterm provides some default styles, and that's why I have this particular import here. Now, where do we initiate the terminal? It has to be some kind of div. So create a div and give it a ref, and that is where the terminal will be mounted. So I'm using useRef from React. It's gonna store the terminal ref, and it is going to initiate a new terminal there. And then we actually open the terminal. And unlike web containers, we can actually dispose the terminal to clean up. So this won't result in any error. Okay, now let me refresh my dev server. And if you notice, you have a terminal here. Unfortunately, you can't type or do anything with it yet. We will get there, but you have a terminal here. The end of line convert EOL, convert end of line option is set to true to always start the cursor at the beginning of the next line. There's some gotchas there. You can read about it. Yeah, like I said, you have a good looking terminal, but it has almost no interactivity and we can't type anything. Let us wire it up to the WebContainer API to make it interactive. All you have to do is back in our app.tsx, we are going to pass this web container to our terminal. Right? It's complaining because I didn't define the types yet. So I'm passing the same web container here. And again, copy the terminal.tsx code. Okay, what happened here? I pass the terminal instance. Again, it can be null or web container. We get this web container type from the web container API. So full type safety there. We also create a new state for our terminal. When my terminal is created, I am storing the terminal instance. Why? Because in the next step, when I'm interacting with my web container, I need that terminal. Start shell process. What it does, it spawns a JSH, a shell process from web container, and it uses our terminals, columns and rows to initiate that terminal process. And then we pipe whatever the output from the process, which is the web container process, back to the terminal. So this immediate line which you saw, this was piped from the web container shell process. Again, most of this stuff is there in the docs. You don't have to worry much about it. Of course, you're free to explore when you need it. But for now, this is essentially the step which will output all the web container process shell, right? It pipes to as a writable stream into terminal. And yeah, we get the terminal.write option. Next, we also want to write to the shell process. How can we do that? Through the input feature. So here we were outputting the shell process. Here we have to input to the shell process. And it gets a writer. All we have to do is whenever the terminal gets some data, right? Like some data, we want to listen for it and then write that to the input. And in fact, that's what I did now. Simple ls command listed out the files available in my web container file system. It already works. Now you'll immediately notice that the terminal experience is not that great. We'll work on it, but essentially this is the step that wires up web container and terminal, an output and an input. Again, you can read if you need more clarity, but don't worry about any of it. Yeah, like I said, the terminal right now has an issue resizing the panel and commands don't wrap. Since like I said, this Xterm is a industry standard tool, there is an add-on, pretty much a plugin called fit add-on, which resizes the terminal whenever the panel is resized. Okay. So, okay, I need to update the instruction, but don't worry about it. We will install the fit add-on using pnpm. It's called Xterm add-on fit. And next we have to import it here. So I'm going to import it. It's a named export. So fit add-on. And all we have to do is whenever the terminal is created, we also create a new instance for the fit add-on. And we simply call fit add-on.fit and we load the fit add-on plugin on the terminal. With this step, things will wrap already. So now, yeah, you can already see that things wrap, but my resize still doesn't work. This is because we need to listen to this resize event and call fit add-on. That's what we're going to do in the next step. So back to my docs. Yeah, resize will still break the terminal style, but the commands will wrap. So we're going to use ResizeObserver to refit the terminal on resize. So this is provided by the browser and it looks something like this. Again, it's another effect because it's an external dependency. The browser API is an external dependency. We will have to use a use effect to synchronize with it. So it's a ResizeObserver. You can call a new ResizeObserver, and whenever the observer it's listening, which is nothing but my terminal ref, which I provide here. Whenever that is resized, we're gonna simply log that things have changed. So you see this? Yeah. Whenever my terminal is resized, you'll see a couple of logs. Now, what we have to do now, whenever such resize happens, we simply have to call the fit add-on, which we created. I am now storing that instance in my ref because I want access to it somewhere else. We can also store it in a state. Ref works here because that never changes. So I create a new fit add-on ref, and this essentially only stores the fit add-on. And whenever my ResizeObserver is changing, is observing for some resize, we simply call current.fit. With this step, you will be able to play around with your resizer. So if I now resize, you see things wrap along with my resize. Now you see this little bug at the bottom where it looks like my terminal still doesn't take full height. Honestly, it's not a huge bug and you don't want to waste your time worrying about such a bug. Like I said, there is a minor bug where resize does leave little space at the bottom of the terminal. We don't want to worry about this bug, and it can be covered by little CSS. I just pushed a commit. I think this should be deployed by now. Yeah. So there was a small minor documentation issues. The instructions were still for version 3 of Tailwind, but I fixed it. So yeah, you can now copy this command. So yeah, in my index.css, just set the dot terminal and apply h full, take the full height, and now you won't notice that bug anymore. The bug is still there, but it's not quite evident. The terminal Xterm has a class.terminal, which we can apply some CSS to fix. That's what I did. I set the height to terminal 100%. Apply h full is the Tailwind way of doing things. Now, even though the ResizeObserver is great, you could still mess up a lot of things. And honestly, using a good library here would help. And that's what I'm going to do now. We're going to use a package called use ResizeObserver. It's a custom hook created by someone nice on the internet. And this will help us completely remove all this custom logic which we wrote. So I'm going to import my ResizeObserver, and it itself gives me another ref, which I provide to my top container because that's a container that's changing. And whenever that container changes, I simply run my fit add-on ref.current.fit. So nothing has changed. It's just that I'm using a different package to do things, which is a good idea. Great. That wraps up this section. In the next section, we will be building our preview, and that is where you will be able to see your actual browser output. Let us build our preview, which is nothing but the browser output. Again, you know the drill. I simply create a new component, call it preview.tsx. And we can replace the preview here with the preview we created. Preview. Great. With that change, you will have your own preview. Now, the way these previews work is nothing but through an iframe. So this is because we don't want to impact our current website, and it's not safe to do so too. We want to put whatever output that comes from web containers into this iframe, and that's what iframes even help us do. So in our preview, I'm creating iframe ref, creating an iframe element. It takes a ref, nothing has changed, height full, w full, border 2. You are noticing a small bug right away. Don't worry about it. It is because the preview struggling to find this loading.html file. We will be creating that soon. In fact, yeah, that's the next step. So we have to create a new file called loading.html at the root of our project. Remember, at the root. And it is where your index.html is also located. So at the top level, I'm going to create my loading.html and use the terminal to run a command. Just quickly paste this and you can see that that bug is gone. And now you'll see a loading state, which is use terminal to run a command. So yeah, we still can't, even though we are able to run commands, run npm install, we still can't output that to our terminal because it's still not connected by the WebContainer API. We just have an iframe. It does nothing at the moment. So we have to wire up. Again, the drill remains the same. We pass the WebContainer instance from our app.tsx to our preview. And in our preview, we receive the web container from our parent, run an effect. So whenever web container, right, whenever it's server ready, so this command will initiate a server. And when that happens, the URL of the iframe is replaced. So there you see our hello world outputs in our iframe now. But there's still a problem. If I make any changes to the editor, those changes are not visible, right? We are not listening for those code editor changes yet. That's what we'll work on now. We have wired the terminal with the web container. We have wired the preview with the web container, but we haven't wired the code editor with the web container yet. And that's what we're going to do now. So copy the app.tsx, new app.tsx, where we pass the web container instance to the code editor. And back in our code editor, all we have to do is receive that web container instance from the parent. On our editor on change, we handle that code change. So whenever the editor value changes, we write it to the web container using the file system and update the active file content. So that's what this command does. And it's an asynchronous command, so we have to wait for such changes. But with this change, now if you make any changes, you would see your hot module reload from Vite happen here right away. Yeah. So npm run dev. You see? It works. So you pretty much have a mini IDE in your browser. Now, yeah, you were able to see that we are able to run a full-fledged React server, React with Vite in the browser. And in fact, I'm not kidding. You can also do stuff like import React from React. And let's say const react.useState hello world. I could call this input, set input. And I could say, yeah, I'm just going to put my input here. I'll also create my fragment. We are using React and Vite, so fragments are very much supported. In fact, we are using Monaco Editor. It has a format document function, which you can use. It's not as good as Pretty, but it's a default VS Code formatting. But let me also put up input. So value equal to input, on change is equal to e, set input to e dot target dot value. Let me format the document again. We don't need this anymore. But yeah, now you have your header and the input, and you see that React state works. This is a great way to write React. So yeah, this was the course. Having a runtime that would allow you to run things like Vite, React, Svelte, Angular, whatever, anything Node.js. Yeah. Having an editor with multiple files. In fact, break something here, it will break your entire application. It's all synced to the web container API. you are able to build such experiences, and you could build a lot of things now, right? In fact, if you go check the source code of bolt.new, they use the WebContainer API to build the AI experience that they have there. So let me quickly show you bolt dot. I think I could find it somewhere. Yeah, let me just go to the. Yeah, I'm in the Stackplates bolt.new template. If you check the package.json, they have the web container API here. It's an internal dependency. Yeah, they use a lot of things. Now, a couple of gotchas. If you're going to deploy this to production and want to showcase or show off to someone, you can reach out to me on Discord, or the docs for web containers specifies how to configure the headers, but it's pretty much the same thing which we did in our Vite config, depending on the provider. If, for example, you are hosting this on Vercel, this is how you do it. Create a Vercel.json file and pretty much have this in the as the content. That should fix your any issues you have deploying web containers to Vercel. And yeah, any other service provider you're using, Web Container API has all the troubleshooting you could encounter, all the browser configuration you might need. For example, if you're working with something like Zen or have any third-party cookies blocked on Chrome or something of those sorts, you can fix that. And if you use something like Sandpack, you don't have to worry about all these browser stuff, because the way Sandpack does is something way different from how web containers work. So maybe sometimes using Sandpack is a better solution for you. But if you want to build a full-fledged IDE experience, Web Container API is the way to go. All right, let me also quickly do a summary. What do we have here? Yeah, though we would love to continue this course to a full-fledged application, I want you to take the lead, use the knowledge you gain. In fact, go read more about the Monaco Editor, the Xterm emulator, and the Web Container API, and try to build something unique. I don't want to put you in a tutorial hell. That's the easiest way to not learn things much or not remember the things you learn. And my goal was to introduce you to the technologies that I've used for the past 3 years. And honestly, these are great technologies and you can build some pretty cool stuff. Not simple CRUD to-do app, but something unique. And this also makes a great project on your resume. Add some AI related stuff, maybe build a mini Bolt clone or a mini Lovable clone. A couple of recruiters would have you on your watch list, or a couple of founders. Anyways, thank you for watching. I hope you enjoyed the course, and let me know how this way of me building the course video works. Do you want me to write along, or do you want me to copy paste and quickly explain the things? This way of doing things is easier. I don't want to sit and type that stuff because I've already written that code while I was making this course, while I was writing the docs, and now again I don't want to do that when I'm building the video too. And this way it helps me release courses faster, convert most of the text content to video. And I honestly also do not want you to type much. I want you to quickly learn this stuff and then go type for your own projects and not be stuck in this tutorial hell. Anyways, thank you, and I'll see you again soon.